E3TTS, Easy End-to-End Diffusion-based Text-to-Speech. We propose Easy End-to-End Diffusion-based Text-to-Speech, a simple and efficient end-to-end text-to-speech model based on diffusion. E3TTS directly takes plain text as input and generates an audio waveform through an iterative refinement process. Unlike many prior work, E3TTS does not rely on any intermediate representations like spectrogram features or alignment information. Instead, E3TTS models the temporal structure of the waveform through the diffusion process. Without relying on additional conditioning information, E3TTS could support flexible latent structure within the given audio. This enables E3TTS to be easily adapted for zero-shot tasks, such as editing without any additional training. Experiments show that E3TTS can generate high-fidelity audio, approaching the performance of a state-of-the-art neural TTS system. Audio samples are available at the project's website. In-context prompt editing for conditional audio generation. Distributional shift is a central challenge in the deployment of machine learning models, as they can be ill-equipped for real-world data. This is particularly evident in text-to-audio generation, where the encoded representations are easily undermined by unseen prompts, which leads to the degradation of generated audio. The limited set of the text-audio pairs remains inadequate for conditional audio generation in the wild, as user prompts are underspecified. In particular, we observe a consistent audio quality degradation in generated audio samples with user prompts, as opposed to training set prompts. To this end, we present a retrieval-based in-context prompt editing framework that leverages the training captions as demonstrative exemplars to revisit the user prompts. We show that the framework enhanced the audio quality across the set of collected user prompts, which were edited with reference to the training captions as exemplars. FlashDecoding ++ faster large language model inference on GPUs. As the large language model, LLM, becomes increasingly important in various domains. However, the following challenges still remain unsolved in accelerating LLM inference. 1. Synchronized partial softmax update. The softmax operation requires a synchronized update operation among each partial softmax result, leading to approximately 20% overheads for the attention computation in LLMs. 2. Underutilized computation of flat gem. The shape of matrices performing gem in LLM inference is flat, leading to underutilized computation and more than 50% performance loss after padding zeros in previous designs. 3. Performance loss due to static data flow. Kernel performance in LLM depends on varied input data features, hardware configurations, etc. A single and static data flow may lead to a 50.25% performance loss for gems of different shapes in LLM inference. We present FlashDecoding ++, a fast LLM inference engine supporting mainstream LLMs and hardware backends. To tackle the above challenges, FlashDecoding ++ creatively proposes 1. Asynchronized softmax with unified max value. FlashDecoding ++ introduces a unified max value technique for different partial softmax computations to avoid synchronization. 2. Flat gem optimization with double buffering. FlashDecoding ++ points out that flat gems with different shapes face varied bottlenecks. Then techniques like double buffering are introduced. 3. Heuristic data flow with hardware resource adaptation. FlashDecoding ++ heuristically optimizes data flow using different hardware resource considering input dynamics. Due to the versatility of optimizations in FlashDecoding ++, FlashDecoding ++ can achieve up to 4.86x and 2.18x speedup on both NVIDIA and AMD GPUs compared to Hugging Face implementations. FlashDecoding ++ also achieves an average speedup of 1.37x compared to state-of-the-art LLM inference engines on mainstream LLMs. RoboGen, towards unleashing infinite data for automated robot learning via generative simulation. We present RoboGen, a generative robotic agent that automatically learns diverse robotic skills at scale via generative simulation. RoboGen leverages the latest advancements in foundation and generative models. Instead of directly using or adapting these models to produce policies or low-level actions, we advocate for a generative scheme, which uses these models to automatically generate diversified tasks, scenes, and training supervisions, thereby scaling up robotic skill learning with minimal human supervision. Our approach equips a robotic agent with a self-guided propose generate learn cycle. The agent first proposes interesting tasks and skills to develop, and then generates corresponding simulation environments by populating pertinent objects and assets with proper spatial configurations. Afterwards, the agent decomposes the proposed high-level task into subtasks, selects the optimal learning approach, reinforcement learning, motion planning, or trajectory optimization, generates required training supervision, and then learns policies to acquire the proposed skill. Our work attempts to extract the extensive and versatile knowledge embedded in large-scale models and transfer them to the field of robotics. Our fully generative pipeline can be queried repeatedly, producing an endless stream of skill demonstrations associated with diverse tasks and environments. RoboVQA, Multimodal Long-Horizon Reasoning for Robotics. We present a scalable, bottom-up, and intrinsically diverse data collection scheme that can be used for high-level reasoning with long and medium horizons, and that has 2.2 times higher throughput compared to traditional narrow top-down step-by-step collection. We collect realistic data by performing any user requests within the entirety of 3 office buildings and using multiple robot and human embodiments. With this data, we show that models trained on all embodiments perform better than ones trained on the robot data only, even when evaluated solely on robot episodes. We find that for a fixed collection budget, it is beneficial to take advantage of cheaper human collection, along with robot collection. We release a large and highly diverse 29,520 unique instructions dataset dubbed RoboVQA, containing 829,502 video-text pairs for robotics-focused visual question answering. We also demonstrate how evaluating real robot experiments with an intervention mechanism enables performing tasks to completion, making it deployable with human oversight, even if imperfect, while also providing a single performance metric. We demonstrate a single video-conditioned model named RoboVQA Video COSA, trained on our dataset that is capable of performing a variety of grounded high-level reasoning tasks in broad realistic settings, with a cognitive intervention rate 46% lower than the zero-shot state-of-the-art visual language model, VLM baseline, and is able to guide real robots through long-horizon tasks. The performance gap with zero-shot state-of-the-art models indicates that a lot of grounded data remains to be collected for real-world deployment, emphasizing the critical need for scalable data collection approaches. Finally, we show that video VLMs significantly outperform single-image VLMs with an average error rate reduction of 19% across all VQA tasks. Data and videos available at the project's website.